Good evening, Titans. This is Mr. Simpson again, and tonight we'll be discussing Lesson 4.2. The essential question is, how can you write an equation of a line when you are given the slope and a point on the line? Now remember, in 4.1 we were able to write the equation of a line in slope-intercept form when we found the slope, but then we were given the y-intercept. Now we're just going to be given a point on the line. So to help us do this, we're going to be using this point-slope form. So I think this is in your book, your journal book, but make sure you have this written down. If not, the point-slope form is a linear equation written in the form of y minus y1 equals m times x minus x1, where again m is equal to our slope, just like it's been, and then the x1 and the y1 is a point on the line. Okay? So now, if we look at the core concept, again, it's just the point-slope form. And if you look here, we have a line graphed. We would find our slope by using the slope formula. And then we use one of the ordered pairs given to us, so the ordered pair given to us, x1, y1, and we substitute it in. And now once we have it in this form, now we can keep it in this form, or we can eliminate parentheses, solve for y, and put it in slope-intercept form, and that's what we'll work on next here. So in this first problem, we're given the slope, and we're given a point on the line. So if we think about point-slope form, which is y minus y1 equals m times x minus x1. Well, again, the first point given to us is our x1, y1. So we'd write it as y minus y1 is a negative 1 equals the slope of a negative 2 times x minus our x1 is 3. And we're done. It says write an equation in point-slope form of the line that passes through the given point and has the given slope. Now the only thing we would do to try to simplify this is we usually never leave the double negative, so we'd write it as y plus 1 equals negative 2 times the quantity x minus 3. And now that's considered point-slope form. Now I'm going to erase this before I do example 2, so if you want to get this down, pause it, and then I'll start example 2. Alright, so for example 2, again, we'll go y minus 0 equals a negative 2/3 times x minus, and x1 is 4. Now to simplify this, again, they just want it left in point-slope form, but we would just go ahead and simplify it to be y equals negative 2/3 times the quantity x minus 4. And that's how it's simplified in point-slope form. Now it says write an equation in slope-intercept form of the line shown. Now again, they give us 2 points, and we could also just make a triangle here and count squares and go 1, 2, 3, 4, and then across 1, 2. And it's going downhill, so I know it's a negative 4 over 2, which actually equals a negative 2. Now that's one way to find the slope. We could also use the ordered pairs to find the slope as well. So we know our m is a negative 2. We don't know the y-intercept because we're not given that portion of the graph. So now what we're going to use is one of the ordered pairs that they give us. So if we look here, and again if I clean this up just a little bit, one of the ordered pairs given to us is 1, 2. So I'm going to use this one to be my x1 and my y1. So again, remember point-slope form is y minus y1 equals m times x minus x1. So we're just going to substitute in what we know. Y minus 2 is equal to a negative 2, which is my m, times x minus 1. But they want us to write it now into slope-intercept form, which is y equals mx plus b. So now we have to simplify this. So the first thing we're going to do is distribute through to get rid of the parentheses. So I have y minus 2 equals negative 2x, and a negative 2 times a negative 1 is plus 2. And now solve for y. So I'm going to add 2 to both sides, And again, make sure you add it with the like terms. And my final answer is y is equal to a negative 2x plus 4. And now that's my answer in slope-intercept form. So now it says write a linear function f with the values f of 4 equals a negative 2 and f of 8 equals 4. Now if you recall, when it's written as f of 4 equals a negative 2, this is my x value and this is my y value. So that's just the ordered pair 4, negative 2. And then this ordered pair, this again is my x, this is my y. That's the ordered pair 8, 4. So again, I must first find my slope. So I'm going to find my slope using the slope formula. So it's the difference of the y's. So I'm going to go 4 minus a negative 2, again taking my y's, all over 8 minus 4. If I do that, keep, change, that's 6 on top. 8 minus 4 is 4, and I reduce that to 3 over 2. Now again, I'm going to use point-slope form, and I'm going to use one of my points. This is the point I'm going to choose to use. 1, because they're both positive values. So I go y minus 4 equals 3 halves times x minus 8. Now again, I need to put this into slope-intercept form. So we're going to go ahead and solve this. I'm going to distribute through first. So I have y minus 4 is equal to 3 halves times x minus, and I have to take 3 halves times 8 over 1. So I cross cancel, and I get 3 times 4 is 12, so that's minus 12. Now I'm not quite done because I want to make it y equal, so I'm going to add 4 to both sides. Again, make sure I'm adding my like terms. So my final answer is y is equal to 3 halves times x minus 8. Alright, now it says write an equation in slope-intercept form of the line that passes through the given points. So again, I'm not going to do both of these, so I'm going to go ahead and do number 4 here. And so again, we have to find the slope. So I'm going to take negative 1 minus a negative 4 all over negative 4 minus 8. I keep, change, that gives me a positive 3. Keep, change, and I get negative 12, reduces to a negative 1/4. And now that's my slope. So now I have y minus, and I'm going to go ahead and use this ordered pair, a negative 4 equals a negative 1/4 times x minus 8. Notice I'm always using point-slope form. Two negatives make the positive there, so that's y plus 4 is equal to, now I'm going to distribute this through. Negative 1/4 times x, negative times a negative is a positive, and a fourth of 8 is 2. Now to solve this, I'm going to subtract 4 from each side, and I get y is equal to a negative 1/4 x minus 2. And there's our final answer. Now again, number 5, we just did one like that on the previous slide, so I'm not going to do that one. You already have an example like that in your notes. So now we're going to take a look at this application problem. And again, we read through this, and this is the table of values, and again, we can find the slope of this table of values. So we're going to use the points 4, 34, and I'm going to use the point 6, 46. So the first thing we're going to do is find the slope. So again, I subtract my y's, 46 minus 34. I'm going to subtract the x's in the same order. I get 12 divided by 2 is 6. So that's my slope, remember. Now I'm going to again use point-slope form, and I'm just going to use this first point that we're given. So y minus y1 would be 34 equals m, which is 6, times the quantity x minus x1, which is 4. And again, we're going to write this into slope-intercept form. So I'm going to distribute this through. I have y minus 34 is equal to 6x minus 24. And I'm going to add 34 to each side. Add 34 to each side. And I get y is equal to 6x plus 10. Alright, and now there's my answer for this. This is the linear model that represents the cost for the number of foam hands. So again, I'd like you to now to open your book, your journal book, to page 104 and attempt to do problems 1, 2, 7, and 8. Again, make sure you're using your notes that you just took, and see if you can't complete numbers 1, 2, 7, and 8 from your journal book. Have a great evening, and I'll see you tomorrow in class, Titans.